Hello everyone and welcome back. So I wanted to show the workflow that I use to render efficiently any complex destruction, and this is something that I've recently implemented and discovered that it's actually possible. I don't think the Arnold team realizes this, and many Houdini users probably will miss this workflow. And so the idea came when I saw that they started supporting Alembic. And I was quite involved in using Alembic and part of the development and testing team at Blizzard. And one of the features that we were trying to add is something called layering, ABC Alembic layering. And at that time, it was not, Alembic didn't have any layering support. And so we had 2 or 3 guys working for about 8 months to implement this feature in the Alembic core, and it was pushed out and released I think 3 years ago, and it became part of the Alembic library. So Alembic now supports layering. But what is this layering thing? Well, the idea is that we want to, let's say, have a character and cache that character one time, and then be able to provide deformation caches for different animations. So the modeling department will cache out the version, and they say, okay, that's the one, and it's approved, and it's only cached one time. We wanted to be able in lighting to bring up the latest animation without having to cache the geometry every time. And the idea consists of importing the geometry itself from modeling and then applying a cache. So that's the layering. Okay, so that's the first layer, but it didn't stop there. We wanted to be able to add extra layers. So let's say the first time the animation was done using the character only, and then a second pass later came that added a wind animation or cloth animation to a cape, for example. That would come in as a separate cache, and we wanted to be able to layer all of this and read them at render time, version everything independently, so we don't have to waste caching time and disk space. This was very efficient, and that's why they spend a lot of time developing this. But it's not only for deforming geometry, it's also applicable for transforming geometry. In our case, this is a transform only cache. Each piece is, let's say, A, B, C, D. Each one is it's static, but it's transforming in space. Okay, so we only need to provide it a matrix that can apply to that geometry at render time. And in our case, we want that geometry to be points. We don't want to cache the geometry again every frame. So we want to be able to read the geometry, high res, or it doesn't matter what the resolution of the mesh is. We want to be able to read that at static frame, at static position at rest, and then read a separate file containing only the transformation, and then combine both of them. Okay, so that's the idea, and I have it working. And I'm going to show how it's currently behaving, and this is the cache. It's static frame. I'm going to go to the first frame. The viewport is only showing the actual geometry, but I'm going to hide it. I'm going to display this. We'll see a square and it doesn't move. Okay, so if we go to the render, and hit render, it's going to show us the first frame. If I play through, it's going to show the cache moving. And I only have one file of the geometry cached to disk. See, it's moving. So how this is happening? Well, when they started supporting Alembic caching or Alembic reading Alembic files at render time, it was a huge feature. So it saves a lot of time because you don't have to cache different formats and you don't have to translate that data to the render. It can read it directly from disk. Okay, so the second part is, how can we access this layering feature? How can we say, okay, Arnold, this is my main Alembic file, and this is my second layer, or my first layer, or my third layer? How are we going to do that? There is no default workflow for that. But if you are familiar with the API or the ASS format, you should know that we can parse and modify any data and pass in extra arguments to the Alembic procedural. So first thing is first, we need two things. We need to save out the geometry the way Alembic wants it. We cannot save the geometry as one set of points. Alembic needs to identify which piece is which. So we need to build what's called hierarchy in the Alembic file. And the easiest way to do that is to cache out the Alembic file. The packed data. So this is my geometry. I'm simply packing it here. So I have 50 packed primitives, and make sure we have a path. This number has to always match. So each object has to have a path. Okay, and this is something that happens with the assemble. When you simply assemble geometry, it creates that path attribute. Don't worry what's stored in there for now. Just that's the data we need. We need one value per set of points, and that's the path. Then we need to cache this data and make sure that it builds the hierarchy that we want. So if I do a drop Alembic output, okay, I'm gonna name it whatever, doesn't matter, and then I'm gonna tick on build hierarchy and make sure that I have a path attribute. Always make sure that you have the data correct. Under the geometry tab, I'm gonna make sure it's a transform geo, and I'm only going to cache one frame. I don't need full path. So I'm gonna call this geo live box cube.abc. I'm gonna save it. One frame, that's it. Okay, so I'm gonna go back up. I'm gonna create a geometry node, and there's two ways to do this. I'm gonna show both of them, and just to cover all the scenarios that you guys may run into. So the first thing, I'm gonna create a geometry node, and I'm gonna dive inside, create an Alembic node, and read the cache, the single frame that we did. So this one. Okay, and then we make sure that it renders. Now, when they added Alembic support, so let's go here and hit render. Cool, our box is rendering, and you can see it's super fast. It didn't take too long to cache the geometry, and the reason for that is because there is no translation. It's reading it from disk. Okay, so it's gonna be super fast. So the next part is, how can we apply our transformation without having to cache the geometry every frame? Well, it's very easy. I'm gonna, after we apply the transformation through the transform node here, we're going to cache this result. Okay, so let me hide everything. So we have our geometry here, and I'm gonna put down I'm gonna copy the Alembic ROP node. I'm gonna call this anim/live or cube transform, and we need the dollar frame because we're gonna cache this every frame. But the most important thing is you have to have the path, and you need to turn off create shape, because if we keep that, then it's gonna store the geometry every frame. So by turning this off, it's gonna only write the transformation matrices. Okay, I'm gonna cache 100 frames and then save this to disk. And you can see it's super fast, and the cache size is going to be very light. So I'm gonna copy this, and then if we go back to the geometry, and here you see they have a number of layers, and this is Houdini supporting the layering of Alembic. It doesn't necessarily mean that Arnold is gonna support this. Okay, so this implementation of Alembic is inside of Houdini. Doesn't mean that Arnold supports all of these and that they will translate. But let's see, maybe they do. So if we go to a different frame and hit render, it's working. So the transformation is working perfectly with this approach. Now this is very new. Okay, previously it was not possible to do this, and I'm gonna show the hacky workflow that hopefully will uncover give you guys some more ideas on how to brute force things. So if I create an Arnold procedural, what's happening under the hood is that the H2A plugin is taking that data and converting into an S argument or a ASS syntax that Arnold understands. So that syntax is basically saying, hey, I have an Arnold procedural, an Alembic procedural, and this is my layers. And I want to show you how we can stitch that together. So I'm going to create an Arnold procedural. Okay, and I'm going to call this Arnold test. And under procedural, it looks like you can only read geometry data, but that's not true. So if we do edit parameter, and this is something hidden, and turn on show hidden attributes, you see there is a translate as and procedural type, and these are hidden by default, and they're very, very important to access. So I'm gonna uncheck and hit apply, and now we get this translate as Arnold procedural. The procedural type is going to be Alembic, and now if I go here and copy the geometry path and paste it here, I'm gonna have an Arnold procedural that's reading Alembic at render time. It's similar to what Arnold is doing, but now we're doing it manually. Okay, so I'm gonna paste this and hit render. So that's our geometry. But with this, we don't have a way to specify that layers information. Okay, and maybe I can do this. Let's turn this on for now. And I'm gonna render this. So it's working. I'm gonna export this as an Alembic, as an AS file. So let's export. And I want to show you the syntax. So this is the file, and let's find the Alembic. There it is. So if we look here, you see this is what Arnold is, H2A is generating. It's passing the file name, and then it's passing the layers, and I'm not going to care about the object path, and then a bunch of other information. Okay, so there is no data here. But the problem when we did this, or the downside, is that you see each Alembic, each primitive is going to have its own procedural. So we have one per piece. If we have 100,000, we're going to have 100,000 of this declaration. So I'm going to show a more efficient way to do this, where it doesn't have to write out one Arnold procedural per piece. And this is going to be way more efficient than the way H2A is translating it. Okay, so here, I'm going to hide this. I'm going to go back into this one. So the next thing is we need to specify our layers attribute. The way we're going to do that is using something called operators. So if I type in operators, or Arnold set parameters. So yeah, set parameters, or and these are called operators. So I'm going to plug this in, and this allows me to modify anything in my scene. So I'm going to select that Alembic procedural or Arnold test, and I'm going to say for the number of elements, I want 1. I'm going to say layers equal. I'm going to paste this path here. Sorry, we need to specify the type first, and then the layers. And this is going to point to the transformation cache with the frame and ABC. So if we, let's turn this off, let's connect this here, and then we make sure that we include the Arnold test. If I hit render now, it's going to work. And now it's no longer exporting one piece per file. It's not creating an Arnold procedural per piece. This is happening as an operator, and it's happening in memory, so it's even more efficient. And this is the most efficient way to render out destruction in general. And it's much better than using doing render time displacement, because let me show you. If we go, so that's our geometry, and it's taking almost less than a second. If I go back here, I'm going to disable this, and let's do a quick geometry increase. Okay, so this is the geo. I'm going to do for each connected piece. And I'm going to remesh this. And I'm going to increase, say, okay, 5,000. Let's see. I'll go even higher. Okay, 0.04. And let's run this. It's going to take some time. So let's put down a compiled block. And maybe I reduce this a bit. So let's put 0.1. And let's see. Let's run this. Okay, much faster. So let's increase it. So I want to increase the geometries to something really, really high, just to show you how it's going to work. Now, there is one downside to this. The downside is, remember that path attribute where we need to make sure when exporting the Alembic file, it needs to have its own path. Each piece has its own path, and that can be very slow to export, because when you have 100,000 pieces, Alembic export process will take some time. If you don't turn on the build path, it's going to be super fast. But what I ended up doing is, if let's say I have 1 million, you divide it into 10 clusters, one per each, and then they can all share the same transformation. So you cache out one transformation, and then you simply separate the 1 million into different clusters, and that way the saving process is much faster. So we have how many points? 1.4 million primitives and almost 1 million points. Okay, so let's cache this. I don't need to recache the points because we didn't change anything. I'm gonna call this 2, and it shouldn't take too long because we didn't increase the number of pieces, we simply increased the number of polygons. And live cube here is 175. And let's go to the camera and call this 2. I'm gonna assign the texture, the shader that we had, and I don't need any edge displacement. I just need texture assignment. That's it. So the image file goes into this, and that's it. I'm gonna increase the brightness of the texture. And if we hit render, let's make sure the set parameter is there, this is there, and if we hit render, let's see, it should start. Yep, there it is. That's 1.5 million points red right away. So even if we go to 10 million, which maybe should test to see, it's gonna be super fast to read. We have our edge displacement, and everything is working as expected. That's it. Thank you guys for watching, and see you in the next video. Bye bye.